I'll give you details, of course, how to download a QR code and enter Pigeonhole to send all your questions through. And now, ladies and gentlemen, we're all ready for a panel. We're very excited to tell you our next panel will be discussing the latest breakthrough in embodied AI tech, from robotics foundational models to humanoid robotics and adaptive learning in real-world setting. Our expert panelists will be discussing about advancement that will enable robotics with generative AI capabilities to navigate unstructured and dynamic environment to collaborate with humans. I'm super interested to know more. Ladies and gentlemen, a little reminder, if you're new to our session here today, we have a QR code for you to scan and to send in your questions. We will do our very best with the time that we have at hand to answer maybe one or two questions towards the end of the panel discussion. So please use the passcode BEYOND to enter Pigeonhole. And with that, ladies and gentlemen, the next session is co-organized by A-Star ARTC, brought to you by Rawside Consortium Asia Pacific, supported by EDV, NRP, and SGI. With great pleasure, I'd like to welcome our panelists to come on stage and to introduce the moderator as well. Director at ASTM International, our moderator today, and first to come on stage is Mr. Aaron Pratha. Let's give him a round of applause. Welcome, Aaron. We also like to, of course, say a very good morning to our panelists as well as they join us on stage. We've got Alvin, James, Dr. Kirsty, and Raphael. And I believe after we assemble our superheroes on stage, we are ready to go with this panel discussion. Ladies and gentlemen, a brand new panel and the first one for this morning. Can we give them a round of applause to begin? Thank you. Over to you, Aaron.
Thank you. Again, thank you for our host and our great sponsors. My name is Aaron Prather. I'm the Director of Robotics and Autonomous Systems Programs at ASTM International. And I'm going to let each one of our esteemed panelists introduce themselves. And we'll kick off. Alvin.
All right, thanks, Aaron. I'm Elvin. I head up engineering, technology, and sustainability at PSA International. I also concurrently head up PSA Ventures, our corporate venture arm. So imagine the two roles. My earlier roles are about development of capabilities, and I also work with business units to deploy them at scale. Then you move a little bit upstream of the innovation value chain. That's where my PSA Ventures roles will go out there and look out for opportunities to invest, venture builds, and maybe take part and collaborate in certain partnerships to push through my agenda. All right, thank you.
Thank you, Alvin. James?
Hello, everyone. I'm James. I'm with Creo Venture. At this moment, we are venture builder and also early stage incubator for the physical and robotics company. Our team has experience to supporting the early stage company from $0 to $1 billion revenue multiple times, starting from niche sector leader to a mainstream market leader. Some of the company you might heard about, like DJI and also the Bloom Energy these days. I've been working for Kleiner Perkins for 16 years period to Creo, and we love to share our scar tissues learnings in the hardware, particular robotics sector today. Thank you, everyone.
Thank you, James. Christy?
Good morning, everybody. My name's Kirsty Hewitson, and I'm from the UK Atomic Energy Authority. We're a government-funded organisation, and you can essentially think of us as the National Lab for Fusion. I run a series of robotics programs, which is a consequence of us leading something called JET, the Joint European Tourist, for about 40 years, which required remote handling solutions. Prior to that, I've worked across defence, life sciences, and also nuclear fission. Thank you.
Thank you. And Rafit?
Hi, everyone. So I'm Raf. I'm the director and head of Griffin Labs. So Griffin Labs is a subsidiary of Landsbot International. We're actually working on frontier robotics R&D. So really in the space of embodied AI and making embodied AI deployable. Prior to that, I was also a software engineer. I worked at startups like Carousel. Yeah, so very happy to be here and speaking about AI. Yeah.
Thank you, Rafi. So as you can see, we're going to be talking about embedded AI, and this is a topic I think you're going to see in numerous talks. It's here, it's not going away. And so what we're going to talk, and from this diverse panel, you can see we have got a very diverse set of experts here, and I'm hoping we're going to go down some rabbit holes. We have plenty of time. We have almost an hour to talk. As mentioned before, the QR code actually sends me the question. So if you have a question that comes up while we're talking, please send it so I can see it, and I can actually ask that from the stage. So your interaction is very important to us. So with that said, I'm going to kick it off. I'm going to send it back to Rafi, actually, and we'll work our way back. Of just how do you each define the current state of embedded AI, and what breakthroughs really excite you right now? So, Rob.
Okay, I think I think the embodied AI space is super exciting, right? Every day you wake up and there's a new humanoid doing new things. You see them walk, you see them fold laundry, and you're like, oh wow, the future is here. So definitely a lot of hype. And when you look at the space as a whole, I think the US is pushing out a lot of very solid, very cool physical AI, general intelligence models. And then in China as well, you see their manufacturing scale just cannot be, it's undeniable, right? Like how cool, how well they're able to scale their manufacturing. But I think at to really pull it back to today, I think there's a huge demo to deployability gap that has not really been addressed. And I think when we want to scale embodied AI, I think we need to be thinking about how we can bridge that gap, reduce that gap from demonstrations, working demonstrations of like walking and dancing to actually solving real problems for our customers, right? So in terms of ROI, in terms of payback period, right? Like how are we going to bring value and real commercial value? I think the state of embodied AI today is, a mix. There's a lot of hype, a lot of promise, but it has to be grounded in just bringing value back to customers. Yeah.
Okay, so our first mention of hype. Okay, we're going to bookmark that one. Christy, what are you seeing?
Yeah, so I have to agree that even when you come here and you walk around the various stalls, how excited do you get about what you see? And I've even said to yourself, "Oh, I want to come to your stall afterwards and have a go on your kit and see how it works." But that application piece is super important, and we'll probably get on to talking about humanoids later, because that is all the buzz around how can we actually use and deploy humanoids in a real environment. And again, from a nuclear decommissioning perspective, it's all about safety first, and then faster, more cost effective. But nuclear also brings its own problems in terms of we're in radiation environments, so how do you rad-hard your electronics? How do you do recovery? And also we have really unstructured environments. So automation isn't really a way forward for us. It's how do we take something into an unstructured environment. From a mobility perspective, I think we're in a pretty good place. Auto recovery, navigation, movement. But where we struggle at the moment, I think, is really around the handling aspect. Thinking about how do we handle things in unstructured environments is still a step we need to progress. And it's great seeing some of the demos here, but they're around very uniform pieces of equipment which you can understand where you're going to pick it up and engage with it.
Excellent points. James?
I think it's very interesting because embodied AI isn't being a new word. It has been existing for 10, 20 years already. So the question I feel for the investor or many of the audience or users will be interesting, why now? Why is becoming very buzzword these days? So I would say as an investor view, we see lots of drivers from technology-wise has been making this more real. For example, some like the transformer, the AI platform as a whole. So the AI transformer model, the reinforcement learning approach, making the perception and the brain, the computation be more efficient and more powerful than ever. So this is the hope we have been seeing in the sector, drive the potential, drive the growth of that, right? The second driver we do see a lot is like the autonomous driving technology. So about 10 years or 15 years ago, people talking about autonomous driving everywhere, robotaxi everywhere. So after very hard working, 10 years later, we have something way more running in US, some of the cities. We have something running in some of the China city and everywhere. So it's coming. So on the other hand, things is getting mature in the EV cars. We also see that technology has been penetrated to consumer-grade products, daily lives. So we have a portfolio companies being in this sector. We call it personal mobility device. We invested 2 years ago. Right now, they have a quite mature demo, and we'll launch their product early next year. So we have a booth here in Switch. Welcome everybody, just go to take a look, try that. So that's the second change we have been seeing. The third is we do see lots of hardware stuff has been happening. And so it's getting mature. So I would say definitely there's a lot of hype about the generalized use of everything. But on the other hand, because of there's a few technology driver we have seen, we have high hope or very optimistic about robotics or like the embodied AI be used in our daily lives.
Thank you, James. I think James just brings up an interesting point is, yeah, embedded AI has been around for 10 years because we've had autonomous cars, but no one ever called that embedded AI. It's an autonomous car. It sounds like autonomous cars were the first use case for embedded AI, and now we have several use cases. So I think we're starting to see the trends here. Okay, Alvin, I want you to bring up, and you've been nodding a lot, so I think you're going to bring us home strong on this question.
I'm going to echo quite a bit of what James has said. I'm going to break it down into two simple parts: software. In recent years, we see a lot of vision, language, and action models coming into this space. And it gives contextualized decision making. We see foundation models allowing us to do generalized tasks beyond the current pre-programmed ones. But more importantly, I think with real to sim and is helping to create more closer to reality models. I think these are the things that excites me because the current robotics we deploy are very rule-based and they are very sequential, and any deviation from what has been then designed for will result in manual interventions. That is really very disruptive for us because we are here to design robotics to displace the human task. If we can't do that, we can't achieve the manpower savings, then everything comes to nothing. We just see very wonderful, expensive robots and metals being deployed at ports, taking up space, but it's not going to be very effective. I'm saying that's the current pain point that we are facing. But with the advent of what I call supply chain capability, I'm going to define that a little bit clearer. If you go out to booth out there, you see robots, you see humanoid robots, and you see actually dexterous hands. This is something that as we pursued earlier R&D programs with the local IHLs here, we don't see that. So we had to 3D print our hands, hopefully to mimic that dexterous hand. So as we want to make it flexible, they lack rigidity. When they lack rigidity, they can't grip the contraptions or what we term as twist locks. I'll mention it a little bit later. Well, so all these things are something that we don't see 5 years ago, and you see suddenly rapid. And it is not just the velocity of this progress, but you see the veracity in terms of the number of companies offering that. And I think this will bring to bear the economics of scale, which is very important because as end users, we are also very price sensitive because if it's not, we can't deploy. I think this simple economics 101, right?
Excellent. And I think based off of how everyone opened on that question, I think we do need to talk about some more use cases of what's making sense out there. And here's the rule. We're not going to talk about autonomous cars. So no one can mention autonomous cars as a use case, but what is a use case that is very exciting? Chrissy, I'm going to open with you because you are working on some very interesting use cases in nuclear of just how's embodied AI just taking what you're doing in nuclear and the use cases that you're trying to solve to that level that you weren't there before?
So I can give you a couple of examples. One is that on our nuclear decommissioning sites, and there's 17 sites across the UK, the largest one being Sellafield, and that costs the UK taxpayer around 2.6 billion pounds per annum in terms of decommissioning. But on that site, we have a number of cells which contain contaminated materials, and at the moment we send humans in typically in air-fed suits. So for those of you who aren't aware of air-fed suits, they're essentially like large plastic bags with an air hose which comes off the back. It takes 2 hours to get into an air-fed suit, to be all taped up, fitted into the suit. You go into the environment, you're doing physical work, you sweat a lot. It takes 2 hours to get out of the suit with health physics. We have stories that when people come out of the suits, the boots they wear, they can tip the sweat out of it because it's so warm. We've recently done an operation where instead of sending operators in the air-fed suits, we've sent in a quadruped instead. First of all, to do the mapping of the environment, and then secondly, to do a clear and clean operation. So going in and actually removing waste from that environment instead. And the operators who did the operation with the quadrupeds were the operators who would normally go in the air-fed suit. So it's not about taking skilled people who have worked within robotics. It's about how do you reskill people who are on the ground, and we'll maybe come on to the cultural aspects later, but how do you reskill those people so we start to look at robots as it's just another tool. It's the same as a screwdriver or a hacksaw. It's nothing special. It's another tool. We can deploy them. We have user-friendly interfaces and actually get them applied. Because I think sometimes when we develop these bits of kit, you do need to be a bit of a specialist in order to be able to work them, but we need to think about that usability aspect.
Okay, James, what's your thoughts on this?
I think if we use a relatively broad definition of embodied AI, actually I do see lots of things that are happening as a closed loop. If you see the world, you have a computation and you can change everything. So I have one to-be case and one consumer case to share. For the to-be case, I think it's for the logistic or warehouse, there's lots of AGVs, lots of autonomous forklift has been running there. So Amazon right now has less and less people in their warehouse or logistic part of the operation, right? So this is the to B sector. If you use a broader definition for embodied AI, basically robots can do many things by themselves, right? Another example we see is a company we invest about 4 or 5 years ago. So they developed this very advanced lawnmower robot. They can cut in your lawn grass by itself by a pure vision solution, which you can see we don't talk about FSD at Tesla at this moment. But basically they use that technology on your consumer robots in your home. So you don't need to waste 2 hours, 3 hours every week to cutting grass. And your grass actually looks very pretty on top of that. So I do feel this consumer plus to B sector, if you have a real business case or use case, people are very love this type of products. So these are the two cases I love to share here.
Okay, Alvin?
Yeah. Pod, I don't think is exactly the most glamorous place to talk about work, but I think a very important piece is the stevedoring activities at the wharf and the vessel. I think you can imagine as you receive your goods you never know how they are being transported on board containers. Maybe I'll just give you a little bit of that, how things are being done over in the port space. So they're obviously stored in containers, but how containers are then being placed on top of each other and being secured, they're being held by these contraption devices called twist locks, right? So they need to be, okay, then for those above deck, to prepare for the high seas, they need to be lashed as well. But I'll leave it as is right now. Assuming those lashing bars have been removed and being brought over by the cranes over to the wharf side, and then they need workers to then remove these twist locks. They are heavy, and they are huge variety. You can imagine there are more than 40 types. Even there are more within the 40 types, every company that produces them have different slight variants to the dimensions, which means that the traditional robotics find extremely difficult to handle, right? So I think this is a very interesting space for us to rely on the dexterous hand, the mobile robots that we see out there to then perform this task, right? Yeah.
Ralph, you want to finish this out with your favorites?
Sure, yeah. So actually, I think for me, boils down to two things, right? Dynamic environments and dynamic task horizons, right? And what do I mean? Well, if you pop over at the Griffin Labs booth, you'll see that we have a data collection set up, right? We have robotic arms that we have operators operating, and the task is to clear the countertop, right? So we have a countertop with trash. Now, from a classical robotics point of view, what you would want to do is you'd want to detect every piece of trash, maybe motion plan, and basically calculate that path towards each of those pieces of trash, and then you pick it up, right? So what happens if you can't detect all of them? Or what happens when, for example, you have semantic sort of information that's needed? For example, in a bathroom, it's not out of place to have a soap bottle, right? But you want to clear something else. So that difference is semantic. It's because we understand the world as it is, right? And so we found that actually using vision language action models has helped us sort of differentiate between very slight nuances between objects in the semantic space. And so dynamic environments now are tractable, right? And then I talked about dynamic task horizons, right? What do I mean? Well, I think if, for example, you have an object on the table, right? And you try to pick it up the first time as a robot, the robot might fail. And then the question is, how much does it retry? Is it going to retry once or twice? Is there a policy, right? It's very heuristics driven, as we've talked about before. But with the AI models, you could just keep it running, right? And it would, because it's been trained to retry and it's been trained to try different angles, you know, it's just gonna do it auto magically in that sense, right? So you don't have that sort of hairy retry mechanism and logic that you'd have to bake into your model. So previously, I think Yadu from Intrinsic was sharing that we moved from models to data-driven like control, right? I think that was a really salient point because it comes back to being able to solve dynamic situations and dynamic environments in a very elegant fashion. Yeah.
So, yeah, go ahead, Chris.
I was just going to say on the object ID, now when we think about it, we often assume that problem's been solved almost in terms of that object identification. We have some problems which are unique to the nuclear environment, which is when we do the object ID through the utilization of cameras, in an active environment, you start to get speckling on your cameras. So you actually start to lose integrity in terms of the data that's being given to allow the object ID. Or we may have cameras on the outside of a cell, which then you're looking through a glass, and then you start to get reflections. So again, you then need to use some clever AI to deconvolute to make sure that you can still identify that object.
Absolutely.
And the same thing happens, right? That it doesn't quite look like how it's been trained. So how does it figure how to pick it up or recognize what it is?
Exactly, and I think like it's not just in, I guess, nuclear reactors, right? Like just reflective surfaces. I mean, AI currently, I mean, a year ago it didn't do very well with reflective surfaces, but now if you ask anyone, like even ChatGPT, right, like, oh, is there water on the surface? It could probably tell you, oh, there's water on the surface, right, and then it could adjust for that. So I think dynamic environments, dynamic tasks, dynamic use cases, from what I'm hearing, is kind of the theme, yeah.
Okay. We've gotten some real good questions from the audience, and one of them actually is a question we were already planning on asking anyway, was what are the challenges that we're starting to face on this? And James, like, and I'm going to start with James on this one, is you brought up like autonomous driving. 10 years we've been doing this. It's not widespread. It's still very limited. So there is something definitely holding it back. And from those like kind of lessons, what else is out there? Is it regulatory? Is it just tech adoption? Is it workforce issues? What's holding us back? I mean, are we just getting stuck in pilot purgatory, or what's going on with some of these projects? James, what's your thoughts?
Thank you. Yeah, I think I probably will stay at a relatively high level at this point. I feel as I mentioned earlier, I'm quite optimistic about the engineer capability development or technology development on that. I feel right now the major challenge will still be the commercial validation, or like whether if we have robots can do many things, whether we have a commercial use case for that. The commercial use case means you not just needed to achieve the task you plan to do, you also needed to achieve that in a cost-effective way that customer like Evan will be satisfied with the investment, right? So I feel we do see some momentum for that. For example, like long grass cutting, which is proven to be attractive for consumers. But on the other hand, many enterprise use case or some unstructured use case, it's difficult to prove the ROI is worth for the money we're spending on that at scale. So I feel we still be quite optimistic about to getting a POC or moving some stuff. But at the end of the day, we have to balance the commercial return for any of the investments. That's also one of the major criteria as an investor. We deploy capital in these sectors. So as you mentioned, robotaxi is great, but it's yet to prove they can making decent money from current infrastructure. So I'm still optimistic about the outcome in the next decade. But on the other hand, we have lots of engineer and hard work to do to deliver the real result.
Alvin, what's your thoughts on this?
Okay, the challenges in my pod environment is I have to describe a little bit more the process for you to appreciate and contextualize what I'm going to say anyway. So I mentioned the twist locks are heavy, they are large variety. So our first attempts at these robots are twofold. One is a huge platform base. So what a space is occupied by two stevedoring workers is just this. Is now being replaced by a contraption that spans 20 over meters in length, another 4 meters in breadth, and another 2.5 meters in height. Just imagine the amount of matter that's now being placed in the wharf. Then we are occupying space that where the trucks also need to navigate, there are people moving around. So it's extremely difficult. So sometimes the containers come in just one, but sometimes come in pairs. So imagine it come in pairs, there are 8 different twist locks to remove, which now can be performed by a human in less than 30 seconds. So you just go there, plug, throw in the bin and all. So imagine that many different types of twist locks are then thrown in one singular bin for a robot to discern, to classify, recognize, and to pick up at the speed of current human is currently very, very close to impossible. Then we start to design, say, hey, if the humans cannot, or rather robots cannot discern in the way human does it, we need to place them on pallets. Then these pallets needs to be transported by a transmission system geared and moved to the end, so there's an end storage. If there's a storage, there's also finite storage of twist locks to serve a certain within a specific base on a vessel. If you run out of it, then you need a human to then top it up. So just imagine the level of difficulty to displace human activities end to end and matching current productivities. So it's a mammoth task to overcome. But like I've said, I'm very encouraged by what we see here. There are more to things that we can do together, but I'll leave it for maybe subsequent questions.
Yep. Ralph, your thoughts?
Yeah. Okay, so I think my answer is going to be very different because we are an embodied AI company, which means we don't have the kind of niche use cases that I think Alvin and Kirsty have shared. But they all point back to what we are really focused on. And I think that why embodied AI has been around for, 10 plus years and has not really seen that success is because everybody focuses on the wrong thing. If you look at the States, right, everybody is looking to build generalized intelligence, right? Generalized intelligence, so locomotion, open world navigation, you're looking at the big picture, when really all the problems are small and narrow. So the problems that we're sharing here in the reactors, in PSA, in the ports, right, are super specialized, super niche. And so I think there needs to be more companies, and we're trying to think in this manner as well, who are thinking about specialized intelligence, right? The big companies, let them do what they're doing, right? The US, they're leading in terms of general intelligence, right? But you will need on-the-job training for your robots, right? If you think about any human, right? Today we get birth, we walk, we learn to explore the world, but we have to go for classes. When you step into a new role, you have to take a training, right? You have to go for on-the-job training. At some point, robots will need these kind of niche, specialized training. And I think if we can shift some of the attention towards some of these like specialized narrow intelligence, I think you could really reduce that gap between demo and deployability. If today I put a humanoid in PSA and I say, hey, I need you to walk from one part to another part, it probably can do it, right? Is it going to adjust your twist lock? I don't think so. And that's where the fine-tuning, that's where the narrow part comes in. So I think that's, to me, what's stopping us from really going all the way. Yeah.
And Chrissy, your thoughts?
Yeah, I guess to Raf's point, we saw that a little bit with the fusion reactor, that when we developed the fusion reactor, we knew that we wouldn't be able to go into that environment, so we developed a remote handling system which would be able to engage with the fusion reactor. So it's making sure that you build your infrastructure, which is almost robot-friendly, but then you bring in your bespokeness, and then when you start to think about commercialization, it becomes one of a kind rather than multiple of a kind or nth of a kind, so then you're limiting your commercial applicability. We've talked a lot about the robots, but where we see some of the barriers in our area, in the nuclear industry, which is, long legacy, lots of people have been working in that area for decades, is they see robots and they almost have an allergic reaction. And that worry is around those robots are going to take my job, or the robot can't do what I want to do. So I told you previously about the quadrupeds which we sent into the active cell. Told you a really nice story, very successful. Was due to cost £1 million, cost 500K instead. Supposed to take 18 months, took 4 months, brilliant. But when the operators first saw the quadruped, they said, that dog cannot do what I do. No chance. And so what we did is we took them off site for 2 days with a couple of our operators who work in that field, and we mocked up the scenario, and we taught them how to drive the quadruped. And by the end of the 2 days, they're like, wow, look at all this stuff it can do. It could do this for us, it could do that for us. We don't need to go into those airfeds. Brilliant, absolutely fantastic. Did the job perfect. And they went, oh, but when we go in our airfed suits, we get paid a bonus. Are we going to get a bonus now? And the managers are like, no, because you didn't go in your airfed suit. And they're like, but we've done it, 12 months faster, 16 months faster. We've saved £500,000. So we've also got to think about this consequence of when we accelerate some of these missions, the impact it has on the human and the individual who's engaging in order to enable them to embrace. It's not just robotics, it's all technologies, right?
And I'm gonna play moderator's advocate here. I'm actually going to become a speaker real quick on this point, because I think as being AAS Team International and we work on standards, we work with IEEE, ISO, several others, and we get asked questions on this a lot of times, not from end users like yourselves or manufacturers like what Raf's doing, but from regulatory agencies, from government agencies asking, how do I know that this is going to be safe for the citizens? How do I know from a regulatory point of view that we're putting safe stuff out there? And we're getting a lot of questions from standards to us standards organizations, because the regulatory agencies are getting concerned, not from, Christy pointed out, from just total workforce change, but just what does this mean to the general public? What does it mean to general workers on their safety? But I think, and we just got a great question from someone in the audience, so I'm going to pivot into this one too, is there's a lot of industries that are just decades old, and ports, energy, healthcare, numerous brown sites. How do you introduce an embedded AI system into those brownfield legacy sites? And Christy, you've sort of already addressed how nuclear is on this. And I'm just going to throw this out. General question, anyone who wants to take it. I'm not going to start with anyone, but what are your thoughts on how do we build this confidence from a regulatory point of view, but also these old industries? As Christy pointed out, they said, no, this ain't going to work, but it took time and you guys figured it out. What's it going to take? Is it standards? Is it showing regulatory agencies this can be done safely, where the AI is augmenting rather than fully disrupting the system and causing chaos? Because that's when regulatory agencies just freeze up and say, no, you can't do it. And they don't give a reason. They just like, no, I don't want to deal with this, stop it. So anyone want to answer that question of how do we do what Christy did for other industries?
I can talk to you a little bit more about what we did.
Yeah, go ahead.
So first of all, we did engage with the regulator. So in the UK, we have the ONR, Office for Nuclear Regulation. So we held a series of sandpits with them. And before you do deployments onto site, they have to be absolutely engaged. The second piece is around communications. So not just with those operations, but broader comms across the different sites around robotics, and robotics is coming. But the other thing we're doing is, and this is a long-term solution, is outreach, both in terms of the local community, but also in terms of schools. Because I'll tell you what, there's a difference, right? So I'll ask the audience a question. So when you see a robot, how do you feel? Excited? Pretty comfortable?
Hands up.
Yeah, we think, yay, robots, brilliant, we've all come here today. Yeah, ow, amazing, yeah? Some people, when they see a robot, they think, Terminator's coming. It's going to take it. People still think that. So it's got to be part of this communication about how do we engage them, because not everybody is comfortable with technology, and not everybody, I see it as a tool now, and I see it as BAU, business as usual, but it absolutely isn't in a lot of the environments, and we've got to recognize that. And so how do you gently introduce it? And we do a lot through outreach.
Yep.
So we have this saying that in Cumbria, which is where I'm from, pretty much every single child will have seen a quadruped, because we do so much going out to the schools, but that's not the same, I recognize, elsewhere.
Anyone else's thoughts on that?
No, yeah, I mean, just to add on. So I think it's very similar here in Singapore as well. I think that people are generally afraid I think the media does a really good job of talking about robots displacing your jobs, right? So I think people tend to be afraid, but when they see a robot, when they see a cleaning robot kind of moving around with eyes and everything, they're like, oh, they're in so much awe, And I think just more cultural sort of like acceptance of robots as just being among us and around us and actually solving problems will really go a long way in this regard. I think NRP and the other the organizations here, institutions in Singapore, really put in a lot of effort in pushing that robotics agenda out into the mainstream, right? And I think it's great. So yeah, I think that's really important. The kids need to see the robots. Yeah, I think yeah.
Yeah, I'll chime in at this point in time. I think we are biggest transshipment hub right here in this part of the world, which means the level of productivity needs to be upkept whenever we introduce such new technologies. We run a very complex, highly orchestrated web of operations that needs to be done from end to end, which means that we really need to think through when we deploy technology. It's not just about running a robot, but you need to think it's going to run a system of robots. Now, when you run a system of robots, then you need to think of not just the current architecture that supports this, but also the future one. You can run POCs very quickly. You may quickly run to a RUT, or you just say, hey, my POC software architecture that manages this fleet of robots is actually not robust enough to meet the uptime of or SLA requirements of 99.9, for example, %. Then you quickly run to problems. The other one is stakeholders engagement. When we started our autonomous truck program 5 years ago, we had to run our trucks in a very, very secluded spot within the port. Then we need to demonstrate to many key stakeholders before we actually introduce to live activities. We have to do it in phases, and then we have to demonstrate safety and productivity numbers before we can scale. But that said, right now, like if we were going to introduce embodied AI in the form of humanoids, I think our election workers will find it very disconcerting, to say the very least. One is, will this robot literally displace my work as well? So there's an element of human resource engagement with unions and all stakeholders to say that, hey, we are doing this to aid at this point in time because our container volume growth is going to continue to grow, and it is to supplement the current workforce, and it's not to really out to displace anyone. I think there are a lot of human factors to consider, not just the technology side of things.
Okay. I mean, I think one of the questions, I've been getting a lot is, we've all seen the viral videos. I get viral videos sent to me all day long from folks saying, hey, Aaron, look at this robot doing it. The funniest one came from my daughter, who sent me a video from her college campus, and apparently all the delivery robots had lost communication and they had all frozen up across campus. And she sent me a video of literally the whole courtyard of 20 dead robots, as she said. And she said, this is a little surreal, Dad. How should I take this? So I think there is something to be said about how the public really looks at these robots. And when bad things happen, even when they just lose connectivity, it's enough to freak people out. Like, what the heck's going on? Is there anything else we can do to calm the public down? Chrissy, it sounds like your outreach. I actually love the idea of hearing that every child in Cumbria is going to know what a quadruped is and know how they operate. Is that what we have to do to get some of these public concerns addressed?
Yeah, and I think for me it links a little bit through to skills as well. So I talk about robotics. We have a facility in Whitehaven, in Cumbria, which is in the north of England. But when we try to recruit, it's actually very difficult to find people who have that past robotics experience. So we're addressing that locally by, well, first of all, we did an exercise with local employers saying, from a skills landscape perspective, where does robotics fit? Where are the gaps? What do you need? And when we first set off on that, we thought we need a new, what we call apprenticeship. So we need a robotics apprenticeship. But actually, when we engaged with employers, we came to the conclusion that actually, when you look at what a lot of roboticists, they're actually either mechanical or electrical engineers, and they've turned their trade to working with robots. So what we're doing instead now is with a couple of local education providers is we've looked at the current apprenticeships in engineering, and there's different levels, levels 2 through to 6 and 7, and we're actually developing modules, so new curricula, robotics modules, which will slot into existing curricula, which the current crops of engineers moving forwards, they'll be trained on those. But for people in the local supply chain who need to train up their people, they'll be able to send their electrical and mechanical engineers on those discrete modules so they can be both standalone. So that curriculum's in development, and it's an offer to the audience here. If you'd like access to that curriculum, it should be written by March next year. We're very happy to make that available worldwide, globally, because we shouldn't be reinventing the wheel. And that's been funded through UK government funding. So again, we need to look for that value add to UK taxpayers. So for us, it's embedding it in terms of local skills and then amplifying that across the UK.
Okay, so that's coming out in March.
Yeah, that'll be coming out in March.
Okay, guys, you heard it here first. March, we got some training coming out.
I'm going to plug it further. It's called CROSS, Cumbria Robotics Operations Skills Center. So please feel free to come and ask me about it.
Okay, we are about to wrap. We are in our final 8 minutes here, and a couple questions have come in that I think Alvin and James. I think you might. I'm going to start with Alvin, but James, I think this question you're going to really know more insights into it. Is from a investment perspective, what's missing? Is there something else that we need to invest in? And I'm going to use this question's line up here. Robot actuator design, sensor fidelity, computer on the edge. What's the breakthrough that's missing that might be able, and does that need more investment? Does it need more research? What's the missing point? So Alvin, I'm going to start with you on this, and then we'll go James back to Chris again.
Yeah, I think first of all is the hardware readiness for our deployment environment. We see dexterous hands, but like I mentioned before, we are high payload, right? Whether can you, our T-stocks are at least 12 kg. Not many hands out there can carry the car payload. The other thing is when you high payloads, you tend to get bigger hands. I do notice that. But you know, our T-stocks, in order to put your finger in to actuate triggers, you need to then to unlock. Some you need to pull wires. Some just simply to wrist and arm action, right? So contrary, you want a strong pair of hands, but you need a small set of fingers to insert. So this is something counterintuitive, but just now I was at a booth of one robotics company. They seem to have one that matches my hand size. So I think they might just be able to cut off for it. But jokes aside, I think the other one is training. We need a means of collecting high fidelity and relevant data points for the robots to train. The other thing is that we are very sensitive to cost, and our POM statements should converge as much with other industry users as far as we can. That's why I think the National Robotics Program Office, led by Ming Fai, and so iPeng is sitting out there. I think they've been schooling me a lot on. They have been sending a lot of research papers for me to read. It's giving me a lot of headache, but I think it's only going to do us well. But that said, I think we need a central repository and engine for us, and I think we need interoperability standards to say that, hey, how do we safely introduce software pieces from a certain person and or hardware pieces from another person? We want to be as agnostic as possible, but that said, we don't spread ourselves too thin. The only way to then configure this in a very meaningful way is to really data exchange through interoperability standards. I think you can attest to that, right?
Yeah, and I'm going to, before I give it to James, we just had a question come in that sort of adds to this whole thing is how do we enable cross-border data exchange? So how can Singapore data go to the US or the UK? How can the UK data come to the Singapore? Is that through standards? Is it through MOUs? So that seems to be another thing that folks are asking is, what is that a missing component as well to get us there? James?
I feel at this stage, there's huge opportunities, but on the other hand, I feel the whole ecosystem need to work together to achieve a more better commercial outcome. The ecosystem I mean here is definitely with right customer, like Evan. You have been experienced multiple failures, but you understand how difficult, and you're willing to try. Right? I feel this type of customer is very important because unless we have that type of customer, we have a chance to deliver. The second, the ecosystem, I frankly speaking, I think investor is very important as well. We have to understand what it take from 0 to 1 and a 1 to billion or $1 million revenue. So it takes lots of failure multiple times until we get success. So I feel investor is important. And the most important part is entrepreneur. Who's the engineers, deliver building stuff, can do this. So we do see great chance of technologies developing. We do see lots of more and more talents in the sector. That's why I say every piece have to contribute together, and including the exchange of the data. I feel Singapore at this point is very important and a great position to address this type of cooperation. And that's kind of my views.
Yeah, I think our three panels before us actually talked about how you shared data and information in Ross. Christy, your thoughts?
Yeah, so I think when we look around here today and we think about what we know worldwide, we can see people are making lots of great hardware, software, and as an end user, actually, we generally buy products, COTS, and make them into MOTS if need be and modify them. But where we struggle is in terms of that multi-platform integration. So we're all making our separate robots, or people are making their separate robots. But if you want to have a multi-robot system, how do you actually combine them all together using the same architecture standards to get them to actually play with one another? And we're not there yet.
And Ralph, you want to close this?
Yeah, so I think on the topic of cross-border sort of data exchange, I think if you really think about what we want robots to be ideally, I mean, from the roboticist sense, is that there's no difference between robot labor and human labor, right? And so cross-border exchange of talent is not something that is foreign. So probably from a policy perspective, there should be some MOUs or some sort of data exchange agreements, and that would really help, accelerate not just actually the functional aspects of the robots, but also the ability for companies to be built and generalized quickly to problems across a general space. But actually, just listening to some of the answers, especially towards the investment part, right? Like I think Alvin has been giving very Singaporean, very pragmatic answers, right? And I love that because I think that when it comes to robotics as a whole now, it's two things, right? One is you got to solve the problem. You got to solve the problem, right? So embodied AI, robotics, whatever it is, you got to solve the problem, and you got to solve it cheap. You got to make sure that you do it in a cost-effective manner. So I think I just wanted to say that. That was a great reminder, for embodied AI companies. Yeah.
Thank you, guys. We did get one last question come in about what about regulations and safety. Great thing. I'm giving a talk this afternoon in the room right behind everyone, where I will actually address this in my master class of how regulations and safety for embedded AI is going right now and where we hope to go. So if you're interested in that topic, please come to my master class. So I get a plug in as the moderator of this. I want to thank our great panelists. Everyone give a round of applause to these.
And also a round of applause for Aaron for moderating as well. Thank you very much.
Thank you. And with that, we are done.
Yeah. Before you go, can I please gather you for a photo? And of course, our official photographer will capture you. If you don't mind, can I please get you to rise and stand close together as we want to say a very big thank you for covering all the challenges, of course, very succinctly put in a panel discussion. If you'd like to come forward,